So figure 8.1 shows an uncharged conducting sphere on insulating stent. The rod and sphere are not moved. Describe how the charge of sphere using a wire connected to earth, and explain whether a sphere become positively charged or a negatively charged. So what will happen first, the rod and the sphere are not moved, but how to charge a sphere using a wire connected to earth. So what will happen when we bring a negative positive charge rod? So it create a distribution, positive charges one side and negative on the other side. And if we connect an earthing wire, from the earthing wire the electrons are attracted here, because positive air positives attract the earthing wire. So positive charges are there, but majority of them are negative, so overall it will be negatively charged. So first, the positively charged rod create a distribution. That is one thing. Then when we connect the earthing wire, allow the electrons to move into the sphere, a conducting sphere. And as a result, there will be a net negative charge on sphere. Then figure 8.2 shows a small black circle that represents a positive charge. We want to draw the electric field. Some of the students, instead of drawing electric field, they drew magnetic field. Like this is a magnetic field for a wire which is carrying current in or out. But we have to draw electric field. And when you're drawing electric field, it's a positive charge, so the electric field line should point outward. And don't draw only like some of the students just do 4 lines like this. But draw the diagonal one as well, which shows that the magnetic field lines are pointing out. Sorry, electric field lines, not magnetic. Electric field lines are pointing outwards. Then a charge of a 7 coulombs flow in 5 minutes. This question looks very easy, but the small change, time should always be in second. So this is 7, that is correct, but the time is not 5 minutes, time should be in second. So we have to convert minute into second. 5 multiplied by 60, that is equals to 300. So it will be 7 multiplied divided by 300. So which is equals to 0.023. So whenever a question is there, the time should always be in seconds. So 0.023 amps is the right answer. Then a figure shows an AC generator. Now you want to complete a cycle using the axis in figure 9.2. Sketch a graph how the voltage output of a generator vary with the time during a period of 0.04, and it complete one. So one cycle it complete in 0.02 seconds. So if you start, it's up to you. You can start with any, like you can start with a maximum number, but you should complete one cycle. This is one cycle in 0.02, or better start as a cycle like as a wave. So this is one complete cycle. So one complete cycle in 0.02, and the second part also in 0.02. So total will be 0.04. So the coil rotate, one complete rotation 0.02. Most of the student did wrong in this question, because you did not consider that this time 0.02, but they only, like some of the students just only draw the cycle. But you have to consider that a time period of rotation is 0.02. So it complete one half rotation in 0.02. So two rotations will be there in 0.04. And the next part, we have to label with the letter A when the coil is vertical. So when the coil is exactly vertical, induced EMF will be 0. So we can mark here, or you can mark here, or you can mark anywhere where the induced EMF is 0. So it's important to check the time period of the rotation to answer this question. Then there is an alternating current in a horizontal wire, and that is buried in a wall. The builder must miss the wire when drill a hole in the. A builder places an instrument using again instrument against the wall that register a reading when it is closed. The instrument include a long coil of a solenoid as an iron core and sensitive voltmeter. Figure 9.3 shows circuit of instrument close to a wire. Why there is a reading on the voltmeter? So why there is a reading on a voltmeter? Because AC alternating current produce variable magnetic field or change in the magnetic field which induce EMF in coil S. Magnetize the iron core. Alternating current produce the change in a. This is the same as the working of a transformer. So alternating current produce change in a magnetic field and magnetize the iron core, and which induce EMF, change in magnetic field induce EMF in the second coil S. State the name and the effect of component X. So what is this X? This component X is a diode. And what is the purpose of the diode? It is used as a rectifier. You can simply say it is a rectifier, or it is used or allow the current to flow only in one direction. Or rectification also it is acceptable. So diode, one thing, one mark for diode. And what is the effect? It can be used as a rectifier. Rectifier means it allow the current to flow in one direction, or you can explain in your own word, allow the current to flow only in one way. The lightning conductor protects a tall building and the people in it against the damage or an injury caused by the lightning strike. The lightning conductor is a very long strip of a copper that is attached. The bottom of a thunder cloud is negatively charged. As a cloud moves closer to the building, the top of the metal becomes charged. State the sign of a charge at the top and explain in terms of particle involved how it becomes that charge. So what will be the charge? Because like charges repel, unlike charges attract. So there will be positive charge here and majority of a negative charge down. And what is the reason for that? Because like charge, you will mention like charges repel, so which allow the electrons to move away from towards the bottom. So here the charge on the top will be positive, and the reason is because the light charges will repel, so it will force electrons to move towards the bottom. As the cloud passes over the building, the lightning strike, which is current is the charge is 0.84 and the time is 3.5. So what is the average current? Current is charge divided by time. So the charge is 0.84 and the time is 3.5 into 10 to the power minus 5. So this will give us how much current will flow. That is about 24,000 at 2.4 exponent 4. Or 24,000 amperes. It is suggested that the current in the lightning conductor could be measured by connecting a lab ammeter. One reason why it cannot be successful, because that is a too high current or very large current can damage the ammeter. The lab ammeters cannot measure too high current. That's why we normally use in milliampere rather than 24,000 ampere. A copper strip has a large cross-sectional area. How increasing a cross-sectional area affects the resistance? So resistance will decrease. And in a space below, draw a symbol for a NOR gate. So NOR gate is a combination of NOT and OR. So this is actually the OR gate. And then to make it NOR. And always label like inputs. This is input 1. This is input 2. And this one is a output. And how we get the result is by adding an invert. So 0 plus 0 is 0, passes to inverter 1. 1 plus 0 is 1, passes to inverter 0. 1 0 is 1, passes to inverter 0. And 1 1 is 1, passes to inverter, make it 0. The fuel of an engine need to be warm in order for engine to work. If the temperature of a fuel is below the working temperature, an LED emits light. On a figure 8.1, a diagram shows a circuit that includes an LED. The component Y is the thermal contact with the fuel. State the name of component X, so that is a variable resistor. And component Y is thermistor, a heat resistor. A fuel is too cold and the LED is emitting light. State and explain what happened to a circuit as the temperature of a fuel increases to a value above TW. Look, right now fuel is too cold, but what happened if the temperature increase? As a result of an increase in temperature, what happened to resistance of a thermistor? Resistance of a thermistor will decrease because that is inversely proportional. If resistance of a thermistor will decrease, so voltage across thermistor will decrease, and thermistor and LED are in parallel, so voltage across LED will also decrease, or the LED will be off. So here the answer, when the temperature increase, the resistance of thermistor decrease. So 1 mark is for increase in temperature, decrease the resistance of thermistor. That is 1 mark. The second is, so as the resistance of a thermistor decrease, the voltage across thermistor will decrease as well. So when the voltage across the thermistor will decrease, as a result, what will happen? Low voltage across LED, light emitting diode, which is in parallel. So it will be off, or it will turn off. Then in figure 8.2, LED is now parallel to component X instead of Y. The temperature of a Y increases below the value and to the value above T. Predict what will happen to the circuit and suggest use of the circuit. Now what will happen? So this, as a result, when the temperature increases, as I mentioned, the temperature of a component Y increase. So as a result, when the temperature increases, what happened to resistance? The resistance of thermistor will decrease, so voltage across thermistor will also decrease. In comparison, voltage across the variable resistor will increase because this is a potential divider circuit. If one side the voltage decrease, the other side the voltage will increase. And now it is in parallel, so what will happen to LED or light emitting diode? So it will be on. So we can use this light emitting diode as an indicator for like example for a heating circuits or a circuit as an indicator to show that the temperature of a fuel increased. So you have to write the answer. What happened in this circuit that the LED will work when the temperature will be high or above the value of TW. And the reason because the more voltage across fixed variable resistors, so more voltage across LED. And application of this circuit, it can be used as a sensor to identify a high temperature or the fuel temperature increases. Two ends of a metal rod are connected by a copper wire to a sensitive ammeter. The rod is placed horizontally and it is moved. The rod is moved upward at a constant speed and EMF is induced. Take two factors how EMF induced can be affected. It can be affected by the speed. It is moved at a constant speed, as I already mentioned. So we cannot change the speed here. So it depends on the length of the rod as well as it depends on the strength of the magnet. Size of a current in ammeter depends on the size of induced EMF. Other factor that affects the size. So the temperature of a conductor can affect, the resistance can also affect, the speed at which it is moving can also affect. Now the direction of a motion of a rod is now changed. It moves at a constant speed towards. So state and explain what happened to the induced EMF. There will be no induced EMF. Why? Because the rod must cut the magnetic field, move perpendicular to the magnetic field. So no EMF induced. What is the reason for that? Because it does not cut the magnetic field, or there is no change in the magnetic field, because between the magnetic poles, the magnetic field is constant. When we move upward, the change in a magnetic field, but within the poles, there is a constant magnetic field. So there is no change in a magnetic field or no induced EMF. Figure 9.3 shows a rectangular coil which is placed horizontally. On a figure, we have to sketch a graph to show how EMF vary for a two complete revolution. So this is a cycle. This is one complete revolution, and this is the second complete revolution. And we have to indicate by an arrow when the coil is horizontal. So when the coil is horizontal, we have to label with letter T. When it is horizontal, the induced EMF will be maximum. So you can label anywhere. Any one point you can label. When it is vertical, the induced EMF will be 0. In question 30, a circuit consists of a 12-volt battery, the 3 resistor, and a switch. The diagram, as you can see, the battery consists of 2-volt cell in series. How many cells should be there to make this 12? So one cell is 2, so there should be 6 cells should be there. So 6 multiplied by 2 makes it 12. The combined resistance of 2 resistors in series. So one is 28, another one is 20. So the combined resistance is a sum in series. So that is equals to 48 ohm. Then the combined resistance of the total circuit. So this is already 48 and this one is 24. So the total resistance is the product divided by sum. So 48 into 24 divided by 48 plus 24. So this answer 48 into 24 by 48 divided by 24, that will give us 16 ohm. So the total resistance of this circuit is equal to 16 ohms. The switch is closed. Calculate the current in 20 ohm. So we want to calculate a current in 20 ohm. Look, they are in series. The total voltage is for 12 and the total resistance is 48. So we know the voltage, we know the resistance. So we can use a formula V equal IR. So V is equals to 12. I is the current and total resistance is 48. So 48 is multiplied. Other side will be divided. So it will be 12 divided by 48, which is 1/4. or equal to 0.25. So 0.25 ampere is the total current as there in series. So same current will flow through each of these two resistors. Then charge flow through 20 ohm in 6 minutes. Time is always time. Whenever you solve, time should always be in seconds. So this is 6 minutes. We multiply it by 60. So 6 multiplied by 6, 36. So 360. And the current was 0.25. So we need a charge. So current is charge divided by time. So charge is current into time. Always write a formula before solving the question. So the current is equals to 0.25 and the charge is equals to 360. So 1 by 4 of 360, that's equal to 90. So this will be equals to 90 coulombs. When a wire hangs loosely between the poles of a magnet, the wire is connected to a power supply. When power supply is switched on, there's a large direct current in the direction from B to A. What happened to a wire? So we have to use a Fleming's left-hand rule. Our index finger point in the direction of a magnetic field. So your index finger should point towards the magnetic field south. This is the direction your index finger, left-hand index finger should point. Your second finger should point up. So this is the first finger pointing in the direction of south. The second finger point in the direction of the current. Where your thumb is pointing, it's on the right-hand side. So this wire will experience the force towards the right-hand side, or wire will move towards. So describe what happened to a wire as the power supply is switched on. So when the power supply is switched on, the wire will experience the force and it will move towards the right-hand side. The power supply is adjusted and now there's a large AC current. So when there's an AC current, the direction of the force will change. First it is outward, then in or right and left. So as a result, what will happen? The wire will start to vibrate. So this wire will vibrate between the magnetic poles. The power supply is removed from a circuit and a galvanometer is connected. The wire is moved quickly to the right. Why the galvanometer register a current? Because the movement of the wire produce change in the magnetic field, which induce EMF. Let's state what is observed on the galvanometer when the wire is moved to the left at the same speed. First, we are moving it right, but now we are moving it left. So as a result, what will happen? It will deflect in opposite direction. The needle will deflect in opposite direction. With same magnitude. Like same amount of direction will be there, but the direction of deflection will be opposite, but the amount of deflection will be same. And state what is observed when a galvanometer, when the wire is moved to the right, which much lower speed, so it will reduce the smaller deflection. As it is a 1 mark, so we don't have to explain why. Only smaller deflection will give you the full mark. Then this was an experiment. We have to plan an experiment as student investigating the resistance of different wires. This is a common thing. Like normally, some of the students are just writing the whole paragraphs. It's not the way. Whenever you want to write the experiment, you should always write the experiment in terms of points so that you don't miss anything. Don't try to write the whole paragraphs, because when you're writing a paragraph, likely you will miss any point. Try to answer the question according to the references which they mention here. Like first thing they ask, in your plan, write a list of suitable metal you will investigate. So which metal we will investigate? We'll investigate example copper, iron, aluminium, and you can also mention any alloy. Then a diagram of a suitable circuit to investigate. So A circuit diagram, we have a power supply, a variable resistor to change the voltage. Then we have this wire, because we are only investigating how the resistance of a wire made from different metal can be affected by the material. So voltmeter in parallel, ammeter in series. A switch will be there. So this is done. Then explain how you carry out the investigation. So how we carry out this investigation? We will place the metal wire, connect a voltmeter, ammeter, and then we will repeat the experiment with different voltages and current, and then repeat the experiment with different types of wires. Then the key variables which we keep same or a constant: the length of a wire, the cross section area, the temperature, because these are the factors which can affect the resistance. Then draw table or tables with a column heading. So table should have a unit, correct unit should also be there in the table or tables. So we can mention, you can make one table or you can make more tables, like for material A, material B. So we'll have a voltage, the reading of the voltmeter, voltage is there, ammeter, and the resistance is there. This is example for say copper, and the same table you can make for, you don't have to write any number, same table you can make for iron and aluminium. Then you can also plot a graph, because the resistance, you can also plot a graph between voltage on y-axis. If voltage on y-axis and current on x-axis, the resistance is equals to slope. So voltage on y-axis, current on x-axis, the slope represent the resistance. And opposite will happen, the current on y-axis and voltage on x-axis, the slope will be reciprocal of resistance. So this is how we plan the experiment to find the resistance, or how the material can affect the resistance. Is it clear? Any question or a doubt related to this?